Out. Like, those are the angles I keep using on the assignment, right? So, like, you're seeing 225 and 315 and 330. And these are really helpful angles. If you know them, it makes your life a lot easier. Okay. So we had kind of started yesterday talking about, like, where these actual numbers on the outside came from. If you add or subtract the reference angle in the different quadrants, that's how you get them. So for example, here in quadrant 4, 330 is really 360 minus the 30-degree angle. So that has a 30-degree reference angle. 315 is 360 minus 45. And 300 is 360 minus 60. So those are coming from, like, subtracting, or maybe in quadrant 3 adding the reference angles on. Okay. It's also a great way, like, for you to, like, make sense of, like, which radian it goes with. Okay. So, you know, in quadrant 1, this is pi 6, pi fourths, and pi thirds. Okay. And then we know we get up to pi halves. But what you'll want to do is, like, you'll start to get kind of familiar. Like, also on the assignment, I have a lot of, like, 7 pi sixths and 5 pi thirds. Well, they match up to one of these angles in degrees. You know, if 180 is pi and 150 is 180 minus 30, then this angle is also pi minus pi 6. So if you take 1 minus 1/6, you get 5 pi over 6. The 135 is 180 minus 45. If you take pi minus pi fourths, you get 3 pi fourths. And 120 is 180 minus 60 degrees, the biggest. So 1 pi minus pi thirds is 2 pi thirds. So there's a connection there into how those are special angles, and just kind of like making yourself aware of these things and looking at these makes it just like seem a little bit easier, that like these things aren't just pulled out of the blue, they come from something. And so down here in quadrant 3, I would be adding the pi 6, pi fourths, and pi thirds. So I have 1 and a 6, which is 7 pi 6. 1 and a fourth, which is 5 pi fourths. 1 and a third, which is 4 pi thirds. And we know this is 3 pi halves. And then the last one are when you take like 2 pi minus. So if you're doing like the 330, remember that's 360 minus 30. If you did 2 pi minus pi 6, that'd be 12 pi 6 minus a pi 6. So that's 11 pi 6. This one is 7 pi fourths, 8 pi fourths minus a pi fourths, and then this is 6 pi thirds minus pi thirds, so 5 pi thirds. But we'll work on that for the rest of the chapter, kind of like exposing ourselves to these angles and making connections. You know, you kind of might notice that, like, if you are working in radians, you kind of know what the reference angle is. So, like, the 30 degrees, what I have on the back, I have my bow ties. If you make this bow tie for 30 degrees, you know, notice all of these angles on this bow tie have something over 6. And all of their reference angles are pi over 6, right? The 30 degrees. So there's also those connections that'll be really helpful for you. So something to go back and look at. Okay, the last thing that we want to talk about is going backwards. So the textbook doesn't actually do this, so I'm just calling it like 9-3 extension, and we're going to do some more later on with inverses and law of sines and law of cosines that aren't in the textbook, but your Algebra 3 or pre-calculus teachers want you to have. Okay. And this is really just like, I would liken it to working backwards. Okay. So we're finding the angles instead of the ratios. Okay. On the worksheet you were doing before, you were saying what the ratio was, positive or negative. Now you're going to tell me what the angle is that has that ratio. So it says in the directions, find the angle, and then it says apostrophe S, or like parenthesis S. Like there could be more than one. Between 0 and 360, or between 0 and 2 pi, so you're thinking about that one positive revolution, that will fit this equation. And it says express your answer in both degrees and radians. So this is going to be a great way for you to kind of get familiar with like which degrees and radians go together. So the cosine of theta is equal to square root 3 over 2. Okay. Cosine of theta is equal to square root 3 over 2. I'd be thinking like this. There's 4 quadrants, right? All students take calculus. Cosine can only be positive in quadrants 4 and 1. So it's not happening here and it's not happening here. And then I need it to be square root 3 over 2. So this is my x over r. So that must mean my triangle, my x is square root 3, my r is 2, this side must be 1, and in this quadrant, we got the square root 3, we got the 2, and this side must be negative 1, right? What angle is right there? Well, the right angle is right here. What angle is at the origin so that the opposite side is 1? A 30-degree angle. So in quadrant 1, wouldn't theta be 30 degrees? And we know that to be pi over 6. Which means this is also 30 degrees right here, right? That's the same. We had to be working from the same angle. Okay. But in quadrant 4, this is 360 minus 30, which is 330. Right? So that's the 330-degree angle. Or you can think about it like 2 pi minus pi 6. 12 pi 6, double the denominator, minus 1 pi 6 is 11 pi 6. So I got 2 times that the cosine will come out to be square root 3 over 2 in quadrant 1 and in quadrant 4. If it's 30 degrees or 330, and we say in radians, those are pi 6 and 11 pi 6. So we'll try another example. Okay, for what angles is the cosecant of theta equal to negative 2? So we're working backwards. We're trying to answer the angle. Do you know cosecants very well? What do you probably know better than cosecant? Sine. Okay, so I usually, if I give you one like this with a cosecant, secant, and cotangent, if you ask me a question about it, I would probably be like, well, I'm really going to think about if I had a cosecant of negative 2, don't I have a sine of negative 1/2? That kind of sticks with me a little bit better. I know sine is y over r. Okay, that one I'm pretty good at. Okay, all students take calculus. This cosecant or sine, whichever one we prefer to look at, is negative. So which quadrants could I be in? In quadrant 2, sine is positive, so we'll nix that one. You can just sit right there. What other one would I nix or keep? Quadrant 1 is nixed, right? All of them are positive. So I got to be in quadrant 3 or 4. Okay. And I just have to figure out like what angles in quadrant 3 and 4 have the sine of negative 1/2. Okay. So I know sine really well. You can just sit right there, Libby. Is y over r. Now remember, in that ratio, it's negative, so your y must be negative because your r is always positive. Okay, which makes sense down here in quadrants 3 and 4. So I'm going to draw a triangle. Doesn't really matter what they look like. My r is 2. My y is -1. What angle must that be right there at the origin? To get a 1 right here. It's another 31, right? This is 30, and this must be a 30-degree reference angle. Right, so that it's a 30, 60, 90 triangle. Because 30 is always has the opposite side be 1. And then to get your angles for your answers, remember this in quadrant 3, you got to add the 30. So it's 180 plus 30, which is 210. And we already did this one. 360 minus 30 is 330. Thank you. And I think it's really handy. I think it's really handy on these to use your reference angles for the radians. So isn't 30 pi 6 right there? So you can take pi plus pi 6. It's 1 1/6 or 7 pi 6. And you can take 2 pi minus pi 6. But they have common denominators, so 2 pi is really 12 pi 6. 12 pi 6 minus pi 6 is 11 pi 6. So, your homework, what you want to finish for Fridays when I'll see you again, okay? Most of us got the majority of the front side done, okay? So you want to finish up these questions on the back. Don't ignore these 3 at the bottom. These are good questions, okay? And then page 3 has 12 questions on the front. That's all you need to do. Page 4 is what we're going to do on Friday, inverse string. So it's just pages 1 through 3 for homework for Friday. And it's just like a matter of working backwards on these. Most of them you'll have 4 answers, 2 in degrees, 2 in radians. Okay, but they're the same 2 angles. Okay, we still have about 10 minutes. So work, ask questions.